Okay, here we go. We're going to throw back to elementary school. Remember when you took these numbers, like if you were multiplying 35 and 11, you would write it as 30 plus 5 and 10 plus a 1, and then you would make the boxes with the 30 on the top, and then the 5 over here, because that's 30 plus 5 is 35, and then you would have like 10 plus 1 over here because that's what 11 is, and then you would do each of these little multiplications here and you get 300 and 50 and 30 and 5, and then you would add all of these things up and you get like, so that's 85, 385. So my answer is 385. Remember that? Okay, you can do the exact same thing with multiplying these things together. Okay, so this is called multiplying with the box method. I'm going to call it the box method the entire unit. I'm going to ask you to be using the box method the whole unit because it visualizes how we do the multiplication. And I just want to make sure that you know like where it comes from, why it works, and have a visual for what's going on, because later in this lesson you're going to see some strategies that rely on this visual method. So here we go. You all might be tempted to say FOIL. And that's not technically wrong because it is a procedure that helps us with this type of multiplication. The only reason that I don't use it is because it doesn't work for once you start having something that looks like it doesn't really work like this. So we're going to see these in the next unit. We're not going to see these this unit, but basically I just want to make sure that we're ready for the following unit. So that's why I'm not using FOIL at all. So let's just set up this same thing. So I'm going to put 3x minus 5 here, and I'm going to put an x plus 1 here, and I'm just going to do each of the individual multiplications here. So remember that there's this invisible multiplication symbol right between these parentheses. So I know that's what I'm doing. Let's see, 3x times x is 3x, or you could just write x squared, which is how we'll write that. If you do 3x times 1, you get 3x. If you do negative 5 times x, you get negative 5x. And then if you do negative 5 times 1, you get negative 5. Okay, and so let's just do a little highlighting here. What do we have that we can combine? We have our 3x squared. We have our negative 5x, whoopsie, negative 5x, and we have our 3x. These two are like terms because they have the same number of x's. So I can write negative 2x's, and then this one is off on its own, so I'll just have to write that separately. Okay, so we just got a quadratic in standard form from this multiplication right here. What that means is that this is also a quadratic equation or quadratic expression. So the whole point of today is to take those quadratic expressions that we saw for the first time like this and make them look like this, okay? We also want to be able to go backwards from here to here. And that's the process that we're going to call factoring. You've seen factoring before in Algebra 9, but we're just going to review it and make sure that you have like the hard ones totally under control today, because we have to kind of raise the level of the difficulty for the problems on in Algebra 2. So what we're going to do is we're going to start with a box method multiplication and think about how we would do this. When we combined our like terms on the previous problem, we got one that looked like this. We got one that looked like this. And then we had two like terms right here and right here. Here's the deal. This number has got to be related to this number. This stuff has got to be related to this stuff. And somehow between the two blue boxes, I have to be able to get 14x. So here's the thing. What we're going to look for is we're going to look for two numbers that multiply to a times c. And then we're also looking for those two numbers to add to what b is. So what is a times c? A is 1, b is 14, c is negative 72. What are two numbers that multiply to a times c is negative 72. So what I'm going to try to do is I'm going to try to figure out factors of 72, negative 72. They're going to be pairs. So I could have negative 1 and I could have 72. I could have negative 2 and 36. I could have negative 3 and 24. I could do 72 divided by 4 is 18. So I could have negative 4 and 18. I could have not 5, 72 divided by 6 is 12, so I could have negative 6 and 12. I could have, let's see, not negative 7, but maybe negative 8, so 72 divided by 8 is 9. So I could have all of these pairs, or I could have the opposites, so I could have the negative versions. So I could have 1 and negative 72, I could have 2 and negative 36, etc. Okay, so these are all of my options. Each of these factor pairs could be my magic pair that multiplies to negative 72 and adds to 14. What is the pair that does that thing? It's this one, because negative 4 times 18 is negative 72, and negative 4 plus 18 is 14. So here's what I'm going to do. The stuff inside this equation has to be equal to the stuff inside the box. So I'm going to rewrite what I have. I have to have a negative 72 here because the only thing that I can put here is got to be this term by itself. That's always going to be true. The other term that I know for sure has to be this x squared. And I know that that has to be there because it's the only term that's going to be like with itself also. The blue boxes are where I have to get creative, and that's where this pair comes from. So I'm going to put a negative 4x here and an 18x here. You could put it in the opposite place too, but these two together add to this, and that's what's really important. So now what I'm going to do is I'm going to try to figure out what goes on the outside of the box. I'm going to try to factor this thing. So what I'm going to look for is common terms between either these two boxes or these two boxes. I'm not going to start other places. I'm just going to start in those two places. This one looks the easiest to me. It's got to be a negative number because they're both negative. There's a negative here and a negative here. And then I know that 4 goes into 72, so I'm going to put 4 because there's a common 4 in there somehow. Okay, well, if this is negative 4, what does this have to be? Well, negative 4 times this spot gives you negative 72, which means that this has to be 18 because we showed right here that this 18 has to work. Okay, since this is 18 right here, this is an 18x, so 18 times what gives you 18x? Well, it's got to be x. And then last but not least, this is an x squared, so x times this has to give you x squared, and so this has to be x. What am I left with? I'm left with the expressions x plus 4, I'm sorry, x minus 4 and x plus 18. So x plus 4, just kidding, x minus 4 and x plus 18. This is equal to this, okay? That's our goal today, is to take this standard form and make it look like factored form, which is what we have now. I'm going to go slowly through this example also, but it's a super similar process. So here's what I'm thinking. In my box method multiplication, if I was going to get this as my answer, somehow this 2x squared has to show up in that box, because this box is the only box that has a like term with itself. So this has to match this. Similarly, this 12 has to be here, because it's the only thing that can match. It's the only like term there. So together, these two, which I have to figure out, have to add to negative 11x. So I'm going to write this out real quick. Okay. And somehow when I do this multiplication, these two numbers right here have to multiply to 12. These two numbers right here have to multiply to 2x. These two things have to multiply to something, and these two things have to multiply to something. Sorry, these two things have to multiply to something, and these two things have to multiply to something to add to negative 11x. So what is AC in this problem? AC is 24, because A is 2 and C is 12. So I'm trying to find numbers that multiply to 24 and add to negative 11. So let's write out the factors of 24. I could have 1 and 24. I could have 2 and 12. I could have 3 and 8. I could have 4 and 6, and then back down. Or I could have, this is a little bit weird, but I could have negative 1 and negative 24. I could have negative 2 and negative 12. I could have negative 3 and negative 8. I could have negative 4 and negative 6. What pair of these add to negative 11 and multiply to 24? They all multiply to 24, but the only pair that adds to negative 11 is this one right here. So that means that the only pair that I can put in the blue boxes is a negative 8x and a negative 3x. Notice everything inside the box right now, all of this stuff adds perfectly up to what we started with, and that's the goal. So I'm going to erase these circles to kind of make it a little bit less confusing. Okay, so let's think about this a little bit. What do I have in common between these two boxes? I have a 3, because 3 goes into 3x and 3 goes into 12. But I'm going to use the negative right here, because that's an indication that something has to be negative at some point. This negative right here also gives you an indication that something up here has to be negative. And it makes sense because this is a positive number right here. So negative 3 times this stuff has to give you positive 12. So this has to be negative 4, because negative 4 times negative 3 is positive 12. Okay, let's see what else we can deduce from this whole thing. I need my negative 3 times this stuff to give me negative 3x. Well, that means that this has to be an x, because I have the negative 3 already. If this is x and this is 2x squared, what am I missing? I'm missing a 2x, because 2x times x gives you 2x squared. Okay, what am I left with? I'm left with an x minus 4 and a 2x minus 3. So my factoring is 2x minus 3 times x minus 4. This and this are equal. They're the same. They mean the same thing. If you multiplied this out again with the box method, you would get exactly this whole thing up here. And that's good, because that's what our goal is. So we have a little bit of a method here. And on the next slide, I'm going to write out some steps for you. Okay. Step 1 is going to be identify A, B, and C. So on where I'm actually going to do my work is A is 4, B is negative 4, C is negative 3. Then step 2 is to find factors of A times C that add to B. Okay, so I'm just going to highlight a little bit here so that we were clear. A times C, A times C is negative 12. B is negative 4. So what are the factors of negative 12 that add to negative 4? So let's write them out. I could have negative 1 and 12. I could have negative 2 and 6. I could have negative 3 and 4. And then I could have negative 4 and 3. I could have negative 6 and 2. And then I could also have 12 and negative 1. Negative 12 and 1. Which pair adds to B? Which pair adds to negative 4? Well, it's got to be this one right here. I don't know why I keep doing that. Right here. So that means now I know I have what goes in the box. So step 3 is going to be create the factoring box. So I'm going to take my A term, put it here. So I'm going to put my 4x squared here. I'm going to put my C term here. And then I'm going to use the terms that I got from here for the other two terms. So I'm going to write negative 6x, negative 6x, and 2x. Notice everything in the box adds to this, so they're equal. So now I need to do the factoring. What's common between negative 6 and negative 3? I think it's negative 3, because negative 3 goes into both of those numbers. If that's negative 3, if this is negative 3, and I'm trying to multiply to negative 3, this spot right here better be 1, because 1 times negative 3 is negative 3. If this spot right here is 1, and this spot is 2x, then this spot better be a 2x. If that spot right there is 2x, and this spot right here is 4x squared, then what am I missing? I'm missing a 2x here. So my factoring is, and you can just make sure that this works because if you check, 2x times -3 is -6x, and so that works out perfectly. So what do I get? My factoring is 2x minus 3 times 2x plus 1. If you multiply this part out right here, you will get 4x squared minus 4x minus 3. You can check that by just using the box method again if you want to, but you will get something that looks exactly the same as this one. A couple of special things that can happen here. Sometimes you're not going to have a b, and so you can use the same 3 steps. So step 1 is identify A, B, and C. Step 2 is find factors of AC that add to B. And step 3 is to factor using the box method. Okay, so AC is -4, B is 0. I know it's 0 because there's nothing written between the x squared and the -1. There's no x term. So what are the numbers that multiply to -4 that add to 0? Well, what are the factors of -4? I get, okay, 1 times -4. I could have 2 times -2. I could have -2 times 2, and I could have -1 times 4. Sorry. Okay, so then what is the one that works? It is either one of these, and it doesn't matter which one you pick because they're the same. So in the box method, I'm going to be, I made a mistake. This right here should be 2. My bad. That's step 2. So I'm going to have a 4x squared here and a -1 here. I'm going to have a 2x here and a -2x here. This whole thing is going to be the same as what you've seen before now. So what's common between this term and this term? It sure looks like the only thing that is common is a -1. That makes this a 1 because -1 times -1 is -1. 1 times this has to give you 2x, so this is better be 2x. 2x times this equals 4x squared, so I better put a 4x, or sorry, not a 4x, a 2x there. So what do I get? I get 2x plus 1, and I get 2x minus 1. This is my factoring of this quadratic. These are equal because if you multiply this times this, you get this. For a problem like this, you can use the box method the same way as you always would. It's just a little bit tricky because you have no C terms. So now C is 0. So A times C is 0. B is 9. So you can do this whole process, but here's what I'm going to say. Maybe it's a little bit easier to think about just what is common between the two terms. Okay, what's in both terms? I have an x and I have an x. And in the 6, there's a 3. And in the 9, there's a 3. So I can factor out this 3 and this 3 and say that there's a 3x in common. This is basically undistributing. So what I have to think about is, what am I missing now? What would I have to distribute to get this stuff back? Well, I've got to have a 2x and I've got to have a 3. So if you check this, you distribute these two together, you get 6x squared, and you distribute these two together and you get 9x. So find the thing that is common between both terms. You can pull that out or factor it out or undistribute it, and then there's your answer. This is your factored form. If you multiply this out, remember you will get what we started with. Okay, here's why we care about this. This right here is the graph of y equals this stuff. This is in factored form, by the way. The question that I'm going to have you answer in the Nearpod right now is, what part of the graph shows you the solutions to this equation where, look, y is 0. Y is 0. What part of the graph shows you that? Okay, so the part of the graph that shows you where the y value is 0 is where y is 0. Where y is 0 along the x-axis. So what this question is asking you is, where does the function cross the x-axis? Okay, well, it crosses the x-axis here and right here. So our goal is to find those answers using factoring and one more step after that. Here's one of those sort of like abstract math things that just makes sense once you start thinking about what it's actually saying. If you have two numbers multiplied together, like A and B, and your answer is 0, then one of them has to be 0. We're going to treat them like you have to solve for what happens if both of them are 0. So what if A is 0 or what if B is 0? Just that so that we get both of our answers. Because remember on the previous slide, the thing crossed the x-axis at 2 places, and so we have to do both things. Okay, so like here's an example. If you have 7 times something and you get 0, this thing has to be 0. Otherwise, there's no other way to make this work. Or if you have something times 18, and that's equal to 0, the only thing that you could put right here has to be 0. So the whole point of this is, obviously, if you take two things together and you multiply them by each other, you get 0. One of them has to be 0. Okay, so here's the whole point of today. If you get an equation that is in standard form like this, and it's equal to 0, one of the things you can do is you can factor it and then apply the zero product property, which is what we just talked about. So I'm going to do this problem because I want to show you what the whole process is going to look like, and then I'm going to ask you to kind of start exploring this a little bit today. We will get a ton of practice with this in the next couple of lessons, but this is really an important part of the year. Here we go. A times C is negative 30. B is negative 13. At this point, I'm just going to come to the answer, and I'm going to ask that you get there with me. If you need to think about the factors of negative 30 that add to negative 13, that's totally fine, but I'm just going to go there. The two numbers we need to use are negative 15 and positive 2. Okay, so in the box method, I'm going to have my 6x squared right here. I'm going to have my negative 5 here. and I'm going to have a negative 15x here and a 2x here. Remember, these things are what I use to make sure I get this in these two boxes when you add them together. So what's common? What is the first thing that I look at and I'm like, oh, I know what's common between these two terms. I'm going to start with these two boxes because it looks like it's going to be simple for me to figure out what's common. I'm pretty sure that this is going to have to be a negative 5. Both things are negative and 5 goes into both of those numbers. If this is negative 5 and this is negative 5, this times this has to give you negative 5. So your answer has to be 1 for this one right here. Okay, if this is 1 and this is 2x, 1 times this has to give you 2x. So this had better be 2x. This is 2x, this is 6x squared. This times this has to give you 6x squared. So this has to be 3x. Okay, what am I left with? I'm left with 2x minus 5 on the top. That's this part right here. And then I have my 3x plus 1 right there. Okay, this, remember that this entire thing right here is equal to this entire thing. And so therefore, I can say that this is equal to 0 because it was equal to 0 here. Okay, I have factored the quadratic equation. Now I'm going to solve using the zero product property. Okay, zero product property says it's this times this gives you 0. So either 2x minus 5 has to be 0 or 3x plus 1 has to be 0. Let's solve each of those equations. These are both two-step equations that you have been doing since middle school. So plus 5, 2x is 5. Divide both sides by 2, divide both sides by 2, and I get x is 5 over 2. Or you could write 2.5, I don't care. On this side, minus 1, I get 3x equals negative 1. Divide both sides by 3, and I get x is negative 1/3. I guess you could say x is negative 0.333333. Okay, I like this better. I like this better. Okay, these are your answers to the equation. That means that if you put either one of these answers in for x here and here, here and here, either place, either way, you will get 0 out. These two solutions are my answers. So x is 5/2 and x is negative 1/3. This is what I'd be looking for you to circle. When you're doing these problems, I do not want you to leave it just with this information. I need to see all of this work because that shows me that you're actually doing the problems and you're understanding where it comes from, why it works, how to do it. Okay, so learning target 4B is I can solve, it says I can use multiple strategies to find real solutions of quadratic equations in standard form. Okay, this equation is in standard form. One of the strategies that you're going to use is factoring with the zero product property. So remember at the beginning of this unit, I was like, hey, you're going to need to be able to use more than one multiple strategies to do these types of problems. This is one of those strategies. In the future, you're going to see other strategies. So you have to be able to do this, and you have to be able to do this multiple ways. So let's do this one way today. AC is negative 30. B is 1, which means you're going to use negative 5 and 6. Again, if you don't believe me, you have to go through the factors of negative 30 and find the pair that adds to 1. That pair is negative 5 and 6. Okay, in the box method, I'm going to put my, that's not that good of a box. Okay, 3x squared here and negative 10 here. I'm going to use my negative 5x and my 6x here. Okay. What's common between these two terms? It's going to be my negative 5, because negative 5 goes into both of them, and they're both negative, so that tells me something. If this is negative 5, this is negative 10, this is going to be positive 2. This is 2, this is 6x, this has to be 3x. And this is 3x, this is 3x squared, this is just got to be x. What do I have at the end of this? I have 3x minus 5 times x plus 2 equals 0. Remember, everything inside the box is equal to this. Therefore, when I factor it, this is also equal to this. Okay, so now I can use the zero product property. I would really like to see you just write out ZPP, because that tells me that you know that you're using the zero product property here. This says 3x minus 5 is equal to 0, and x plus 2 is equal to 0. So 3x is 5, divide by 3, divide by 3. I get x is 5/3. Circle it. 5/3, it's just going to look like a 6. Okay. Minus 2, and I get x is negative 2. Hey, here are your two answers. You should highlight them, circle them, tell me that they're your answer, whatever, to show me that that's what you get. Okay, so that is solving strategy number 1. You are going to factor using the box method, and then use the zero product property to solve for x. By the way, this also works if you are already in factored form. You can just apply the zero product property right away. Hey, by the way, if you have a coefficient out here, you can divide both sides by 3, and this becomes 1. 0 divided by 3 is still 0. So what do you have? You have 2x plus 7, x minus 3 equals 0. Your zero product property right away says 2x plus 7 equals 0, and x minus 3 equals 0. Solve. X is negative 7/2. I get x is 3. Your two answers are negative 7/2 and 3. Okay, so I know that this was sort of like so many different example problems, but I really wanted to show you the process a bunch of different times so that you really get the rhythm of it. If you are stuck and you're like, I just don't get this, I think it's really important that maybe you take some time to literally write out the problems that I did, and then also try those practice problems that are in the book. Then there's a mastery check at the end of the day, and you are done. Have a good day.